two-port network models. The feedback network placed around the feed-forward amplifier can be considered a two-port circuit sensing and producing voltages or currents. Recall from basic circuit theory that a two-port linear and time invariant network can be represented by any of the four models shown in figure. The Z model in figure A consists of input and the output impedances in series with current dependent voltage sources, whereas the Y model in figure B comprises input and output admittances in parallel with voltage dependent current sources. The hybrid models of figures C and D incorporate a combination of impedances linear two-port network models and admittances. Here you can see the figure linear two-port network models and admittances and voltage sources and current loads. Each model is described by two equations. For the Z model we have V1 equal to V11. We have V1 is equal to Z11 I1 plus Z12 I2, V2 equal to Z21 I1 plus Z22 I2. Each Z parameter has dimension of impedance and is obtained by leaving one port open. Example, Z11 equal to V1 I1 when I2 equal to 0. Similarly for the Y model, I1 equal to V11, I1 equal to I1 equal to Y11 V1 plus I12 V2, I2 equal to Y21 V1 plus Y22 V2, where each Y parameter is calculated by shorting one port. Example, Y11 equal to Y1 by V1, where then V2 equal to 0. For the H model, I1 equal to V1 equal to H11 I1 plus H12 V2, I2 equal to H21 I1 plus H22 V2. And for the G model, I1 equal to G11 V1 plus G12 I2, V2 equal to G21 V1 plus G22 I2. Note that for example Y11 may not be equal to the inverse of Z11 because the two are obtained under different conditions. The output is shortened for the former but left open for the latter. In order to simplify the analysis of the loading due to the feedback network, we must select a suitable model from the above. We assume the input port of the feedback network is connected to the output port of the feed-forward amplifier. Let us begin with the voltage feedback. Which model should be used? We note that the ideal feedback network in this case must exhibit infinite input impedance and zero output impedance. Thus Z model is not suitable because as Z11 tends to infinity for a finite V1, I1 tends to 0 and Z21 I1 tends to 0. That is, if the input impedance approaches infinity, the output voltage drops to 0. How about the Y model? In this case, if Y11 tends to 0, the output voltage remains finite, but if Y22 approaches infinity, the current source Y21 V1 generates a 0 output voltage. That is, if the Output impedance of the feedback network approaches zero, so as it becomes more ideal, then the output voltage of the feedback network drops to zero as well. With these observations, we summarize that the G model is the most suitable one for voltage feedback, and the ideal case G11 equals 0, G22 equals 0, and G21 V1 is not equal to 0. Using similar arguments, the reader can show that the other three types of feedback require the following network models: voltage current Y model, current voltage Z model, and current H model. Thank you.